Hello. In this lesson, I'm going to talk about price elasticity of demand. So, price elasticity of demand, which is also written as P dot E dot D. Price elasticity of demand represents the responsiveness of quantity demanded, QD, due to changes in price, or P. It basically represents diagrammatically when you have a quantity demand line which is downward sloping, you have price on the y-axis and quantity demand on the x-axis. It represents how much does quantity demand change due to changes in price. So in this case you can see that this much change in price, this much fall in price resulted in that much change in quantity demanded. So naturally, when you have a demand line which is steeper, in this case, the responsiveness of changes in price to quantity demanded is not that much. As you can see here that the price fell by this much, but quantity demand did not rise by a lot. However, in this instance, when the curve is slightly more horizontal, in this case, a small change in price can result in such a big change in quantity demand. And that's what you call an elastic demand curve. And so what you have is an elastic demand curve, i.e. the quantity demand is very responsive to changes in price. And you have an inelastic demand curve where the quantity demand is not very responsive. But what I want to talk about in this tutorial was the relationship between elasticity of demand and total revenue. So price elasticity of demand is measured at percentage change. This triangle represents change in quantity demand due to percentage change in price. So this is divided by percentage change in price. Notice here that we are using percentage changes, and this is because to bring the unit of measurement for both of these things into one, because we know that the price is represented by currency, so for example pounds or US dollars, whereas quantity demand is represented by volume, let's say 10 pieces of bread, 5 pieces of bread. So for us to bring them into one unit of measurement, we take a percentage change in both of them. And the percentage change for anything is basically the new value minus the old value divided by the old value multiplied by 100. Notice also here in this case that the price elasticity of demand is different to the gradient of the line or the slope of the line. So for example, we know in mathematics when a line is more vertical that the gradient of the line is higher, it has a higher number as compared to a line which is sort of flatter. In elasticity of demand is the opposite. And that's because in elasticity, in the gradient, is really change in y divided by change in x. Whereas in elasticity, it's the opposite, where it's change in x, because the x is quantity demanded and y is price. So it's the opposite of what you have in gradient. On top of that, in elasticity, we use percentage changes. So a confusion that sometimes students have is the elasticity is sometimes they get confused with it with the gradient of the line. In fact, it's actually the opposite of what the gradient would be. Right. So we also know that total revenue is equals to price multiplied by quantity. So for example, if a piece of bread costs you £10 and someone wants to buy 10 units of bread, sorry, there's no pound sign there, then the total revenue in this case for the seller of the bread is £100. You can represent the change in total revenue approximately, and I say approximately because there's a mathematical reason why it's not exactly the same. You can represent the change in total revenue by changes in price plus changes in quantity. Now, because both of these things move in opposite directions, changing in price, let's say a price rise, will actually result in a fall in quantity demand because they have an inverse relationship. When a price rises for a product, people usually demand less of it. So for us to find the net effect on the total revenue, what you have to find is whether the rise in price, how much is outweighed by the fall in quantity. If the fall in quantity is more than the rise in price, then the percentage change in total revenue will actually be a fall. Similarly, if they both equate each other and you increase the price and the quantity demand falls, if both the rise and fall equals, the total revenue remain the same. So that's the relationship between elasticity of demand and total revenue. So let's use an example. Let's use a product which has price of £10 unit price, and you get consumers demand 100 units of it. However, when the price rises to £15, consumers demand only 80 units of it. So in this case, the total revenue for the seller of this product would be 100 multiplied by 10, it's going to be £1,000. And 80 times 15 is £1,200. So you can see here that with the rise in price, the total revenue increased. And that sort of tells us something about the elasticity of demand. It tells us that when the price, the percentage rise in price, if you want to calculate, it's going to be 15 minus 10 divided by 10 times 100. It's going to be 50%. So the price increased by 50%. And the quantity fell by 80 minus 100 divided by 100 times 100. It fell by 20%. So the net effect on total revenue would be rise in price of 50% plus fall in quantity demanded of 20%. The net effect would be a rise in total revenue of 30%. Now note here I said it was approximately equal, because in the previous example 1200 to 1000 actually 20%, where we're getting a 30%, but the moment the change in direction will be the same. So as you can see here in this example, when you increase the price, your total revenue rose by 30%. Now it could have been possible that total revenue would have fell, and that would have been the case if this good was elastic, and that would be basically when the quantities demanded fall would have outweighed the rise in price. So the implication of price elasticity of demand with this relationship with total revenue is basically for a good which is price elastic, which basically means the percentage change in quantity demand is going to be more than the percentage change in price. In this case, if the seller decides to increase the price, that will actually result in a fall in total revenue, because the fall in quantity demand in this case is going to outweigh the rise in price, i.e. the goods quantity demand is very responsive to changes in price. Similarly, if a good which is price inelastic, in this case the good idea is actually to increase the price for you to increase your total revenue, because the percentage change in quantity demand is going to be outweighed by the percentage change in price. And in this case, the total revenue will rise, because if you increase the price, the quantity demand is not that responsive to changes in price, i.e. it's not going to fall by that big an amount. In fact, the amount is going to be smaller than the change in price, and as a result, your total revenue is going to rise. Now finally, if the price elasticity was unitary, in this case, the percentage change in quantity demand is equals to percentage change in price. In this case, if you increase the price or if you decrease the price, the percentage change in quantity demand will be exactly equal to percentage change in price, and as a result, your total revenue is going to remain unchanged. So that's the relationship between price elasticity of demand and total revenue. And just to summarize, when your good is price elastic, for you to increase your total revenue, the better idea is actually to reduce your price. When your good is price inelastic, a better idea is actually to increase your price to increase your revenue. I hope you find this tutorial useful. Thanks for watching.